Hello everyone, welcome to my chemistry channel B.L.DASH, short and sweet in chemistry. Now I am going to explain the short revision of reactions in organic chemistry, especially that is class 11 and chapter is alkene. In alkene, here so many reactions I have explained in previous video. What are the chemical reaction involved in the preparation of alkene, and also what are the reactions involved in the properties of alkene. Now here part 12 I am going to explain some reactions, that is ozonolysis and polymerization. What is ozonolysis? You know ozone, that means it comes from the word ozone. Ozone here you will use ozone in alkene. When alkene react with ozone and the condition is inert solvent, that is CCl4. CCl4 means carbon tetrachloride. That means alkane react with ozone, and in presence of CCl4, which is an inert solvent, it gives ozonide. Ozonide means here 3 oxygen will attach in alkene, and when ozonide react with zinc and water, it gives small molecules, generally aldehyde. So see here the process is called ozonolysis, and which detects the position of double bond. We detect the position of double bond mean where the double bond present, that will break. So it will give different small molecules. So here it will detect the position double bond. Similarly, it is also useful for the triple bond also. We can also detect where the triple bond is present. Now see the simple one, ethene. Ethene is the simplest alkene, where you treat ozone and in presence of CCl4 inert solvent, which is called inert solvent, it gives ethylene ozonide, or you can say ethene ozonide. Ethylene ozonide, or you can say ethene. Ethene is the that is IPS name, where ethylene is the common name. And now when treat with zinc and water, it gives methanol. Again see CH2 double bond CH2, where it react with ozone, and here it will give ethylene ozonide. Ethylene ozonide when react with zinc and water, it gives methanol. That means the question is, how can you know that it will produce methanol, not others? Because here you can see, you can break here. This like and this like you can break. You can see here only possible SCHO and one oxygen left, and that is a byproduct as H2O2, hydrogen peroxide. Similarly, here CH3CH double bond CH2. What is that one? Propene. In propene, when you treat ozone, it gives here that is propene ozonide. See propene ozonide, CH3, here CH3CH, you put CH3CH, and here where double bond is present, here the bond will break and 2 oxygen below and 1 oxygen above. It is attached in such a way that it satisfies the that means the bond, double bond of oxygen. Here what is the valence, what is the bond here? Oxygen having 2 bonds. So one side this side and one is this side, so it is known as propene ozonide. Again see, propene when react with ozone, it gives propene ozonide. How can you know? Because it will present like this here. Now and here the double bond breaks and it gives 2 oxygen here, 1 oxygen there, and that is called propene ozonide. See here propene ozonide when react to zinc and water, here this part will break, here this part will break, and here also this part will break. Now when this part will break, you imagine yourself CH3CHO, CH3CHO, not here anything, because here H only there, so it is H. Okay, so CH3CHO, ethanol and methanol. Why it is methanol? Because only when you break this one, this is SCHO. When you break this one, then it is CH3CHO, ethanol and methanol. Ethanol and methanol, there are two main products. And what is the byproduct? Because oxygen is there. So we will write here H2O. What? S2O2, sorry. S2O2. That means the byproduct is always S2O2. Again, see very carefully what is mean ozonide. When alkene react with ozone in presence of inert solvent, example carbon tetrachloride, it gives alkene ozonide. Alkene ozonide, when react with zinc and water, it will produce the corresponding aldehyde, alkanal. What is the IUPAC name for aldehyde? Alkanal. See, ethene is the simplest one. It gives ethylene ozonide. It breaks like this. It gives methanol 2 times. Because 2 parts break, so it gives 2 times. And now, propene when breaks with help of ozone and carbon tetrachloride like this. And now here this part gives ethanol. This part gives methanol. So the answer is methanol and ethanol, and oxygen is remaining. This oxygen that combine with water and produce hydrogen peroxide as the byproduct. You will see other ozonolysis of alkene examples. Now second example of ozonide. That means you will take 2-methyl propene. Before that you have taken only propene. Now you will take 2, see 1, 2, 3. That means here 1, 2, 3. 2-methyl propene on ozonolysis with help of CCl4 gives ozonide. Corresponding ozonide. The bond will break here. The bond will break here, and here ozone is added, 3 oxygen is added. That means below side 2 oxygen, above 1 oxygen, and now after treating zinc and water, it will break like this. When it will break, what is the product you see? CH3CO. That means it is one product, and other one is CH2 only, so SCHO. That means this is propanone, this is methanol. Again see, this is propanone because there is no hydrogen, only CH3, and this is methanol. Now next is 2, 1, 2, 3, 4. 2, 3 dimethyl but, 2 in. After 2 there is a double bond, 2 in. But, 4 carbon, 2, 3 dimethyl. 2, 3 dimethyl but, 2 in. O3 when you are adding, when ozone is added, then what happens? Here the bond will break, here the bond will break, and here what happened? It gives ozonide, because the oxygen, here 2 oxygen is added and above 1 oxygen is added, and now the structure become like this: CH3 one side, CH3 other side, 2 oxygen down, 2 oxygen up, and this is ozonide, corresponding ozonide. That means you can say 2, 3 dimethyl butene ozonide and corresponding ozonide. So that is why I am telling corresponding ozonide, and zinc and water, and here it will break, here it will break, and here also it will break. See, this is 1 propanone, this is 1 propanone, so 2 propanone. And you know here the byproduct is hydrogen peroxide. Always you should write hydrogen peroxide as a byproduct. Now you can, it is easy when it will break, where it will break. That means in double bond, and 2 oxygen on the downside, 1 oxygen on the upside. So it can it is easily understood that, because you can see the structure of the alkene, and you can see what type of either ketone or aldehyde will form. Here ketone, that is propanone, and here it is formaldehyde, or you can say methanol. Now here also one side, that is propanone, other side also propanone, and the byproduct is hydrogen peroxide. And this is called ozonolysis reaction, ozonolysis product. Then we will come to polymerization. What do you mean by polymerization? Poly, so many, merization means multiple. That means here single compound is called monomer. If two compound is called dimer, three is called trimer. So many, a large number, it is called polymer. And the process is called polymerization. So many compounds, single compound will join. Just like you think flower garland. One flower, you can say it is rose flower, okay. When there is 100 to 200 flowers joined and it is formed in a big garland having 200 flowers, then it is called polymerization. One single flower is called monomer. Monomer, single monomers, when joined, so many monomers joined by the help of high pressure, high temperature and some catalyst, then it forms polymerization of alkane and polymers of alkane, and the process is called polymerization. I hope it is easy. See again, if you say a garland full of flowers, each flower, same flower, just like you take rose, then each one rose is called monomer and total garland is called polymers. And the process how to put in a garland, that process is called polymerization. Similarly, monomer, when you take monomer, just like let ethene, that is called monomer. When you join by large number, that is called small n. When they join with the help of alkene monomers, that is high temperature, is polymers of alkane, and that process is called polymerization. Now example ethene, and is same high temperature, unless high temperature, pressure and catalyst, there is no polymerization takes place. Now it is called polyethene, because then the question is, how can you write this one? Because polyethene, suppose n is 1000, you can't write 1000 such a big formula. Then how to write n 1000? Then you put in bracket, that is a part of the polymer. The part of the polymers you can't put from the beginning, you can't put the end, you can't put the first one and last one, only a part where we can show what molecules should be present. Now see, here the total is that is indication of the n molecules, and in 100, 2000, like this, do anyone, and after that here put bracket, that means it is a part of the polymer, that is polyethene. Similarly, propene. Propene you take n, that is n times is a very large number. You take a large quantity, large number of propane, and under the high pressure temperature catalyst, you will get here. If I will put this side CH3, then the valency of carbon more than 5. That is why I have to put the CH3 on the downside, and here this is the only a part of the this polymer, that is called polypropene, and whole to n mean n is a large number. So you can't start, you can't end, you show only part of that polymer, which one you are taking, that what is monomers and what is the number. N is a large number, monomers you will write, and you will put polymer as a part of the polymer. You can't write the whole polymer, and this process is called polymerization. Actually, in 12th class there is a chapter that is polymerization in 12th class second part. So at that time I hope it is clear, it will clear to you, and you can understand easily at that time. So I hope this is ozonolysis and polymerization is clear to you, and read carefully, read ozonolysis reaction, how it will take place, where it will break, where the oxygens are attached, and how they will break by the help of zinc and water. And hope you will subscribe my channel B.L.DASH, short and sweet in chemistry. And also I hope you will share and like my channel, and thanks for watching my video. Thanks again to all.